Hello and welcome to A-Level Math. In the previous video, we had discussed about functions as a special case of relations. We discussed functions as something like a set of ordered pairs, right? We thought of a function as a special type of relation with some special properties. You remember that a function needs to have for every element in the set x, it needs to have a unique element in the set y, and so on and so forth. If you haven't seen the video, I'd like you to go through the previous videos. The links are given in the description and in the I button above. So in today's video, we are going to discuss functions as some sort of graphs. So when we'll be thinking about functions, we have to think of them like a graph. So you have to think of them like an input and an output. So you feed in this function some input and it throws at you some output. So you have to make sure that you understand the basics of real valued functions. What are their domains and codomains? So when I say real valued functions, I mean that these functions are going to take some real numbers as input and throw out some real number as output. So that's the meaning of real valued functions, and that is what we are going to discuss in this entire video. So functions in specific, we have to discuss about real valued functions. Means that say for example, you have any function fx. So this x is the input. You feed in some value to it, like f of 2 or f of minus 3 or anything, and it throws some output. Say f of minus 3 is equal to 5 or f of 2 is equal to 8 or anything. So these 2 minus 3, in general this x is the input, and these 8, 5 or something, whatever it is, fx say equal to y, this y is called the output. So if this x is the input, and this y is the output. Now what real valued functions mean is that this x has to belong to real numbers and this y also has to belong to the set of real numbers. That's the meaning of real valued functions. That means the domain has to be a subset. The domain has to be a subset of real numbers, as well as the codomain has to be a subset of real numbers. This is the meaning of real valued functions. Alright. So formally speaking, a function f that goes from x to y means that x is the domain and y is the codomain, is called a real valued function if x and y are both subsets of the real number. Okay, the set of all real numbers. Okay, let's straight away jump to some example. Alright, I told you that every function takes in some input and gives you some output. Okay, so you can give it any input as you wish, require that, but you just require that you feed in some value from its domain. Alright, you cannot give it some value for which is not defined. We will have an entire discussion on domains and codomains in the later part of this video itself, and we have a lot of examples for you for ease of understanding. And believe me, we are going to cover almost everything, every type of questions that you will be encountering in your examinations on domains, codomains and ranges from functions. Okay, so let's take up this question. You are given a function fx is equal to x minus 1 divided by x plus 1. And remember that x cannot be equal to minus 1, because I told you you can feed in any value of x provided that it gives you some sensible value. But think, if you feed in x equal to minus 1 over here, so in the denominator you will be having minus 1 plus 1. That means you'll be having 0 as the denominator, and you already know that division by 0 is not possible. It will give you undefined results. So that means the domain here doesn't consist of minus 1. So that is why they have specifically mentioned that x cannot be equal to minus 1. Alright, so you have to understand these things from now on, that all those values of x for which the function will give you undefined results, you have to pay special attention to them. Alright, okay, now they ask you to prove that f of fx is equal to minus 1 by x. Alright, so what does f of fx mean? So remember, if you are given f of x is this thing, x minus 1 by x plus 1, and when I ask you to find out f of 2, what do? You just plug in x equal to 2, right? So f of 2 will be 2 minus 1 by 2 plus 1, which is equal to 1 by 3, right? And similarly, if I ask you to find out f of 3, you'll just plug in 3 in place of x, right? So it will be 3 minus 1 by 3 plus 1. Now the question asks us to find out f of fx. So that just means that you have to plug in fx in place of x, right? Think of this fx as 2 or 3. So you have to just plug in fx in place of x. So you'll be getting fx minus 1 by f of x plus 1. And f of x is already known to you, right? This is the form of fx. X minus 1 by x plus 1. So we just replace this value fx by its functional value, minus 1 divided by x minus 1 by x plus 1 and plus 1, and then we simplify. So what do? We take x plus 1 as the LCM, so we get x minus 1 minus x plus 1 divided by, again x plus 1 as LCM, x minus 1 plus x plus 1. Now on simplification, it will give us x and x gets cancelled out, so we'll be having minus 1 divided by x plus 1 whole divided by, here x plus x will give you 2x, and minus 1 plus 1 will get cancelled out, so you'll be having this thing, right? So let's simplify it quickly and see what do we have. Now we do the reciprocal of the denominator. So x plus 1 and x plus 1 gets cancelled out, 2 and 2 gets cancelled out. What we are left with is minus 1 over x, and that is what was required to prove. Alright, so this is our answer. And here also know that x not equal to 0, they have mentioned it specifically because for this function, this actually is a function, it's called a composite function. So for this function is not defined when x is equal to 0, because in the denominator we will be having 0 in that case. So that is why they have specifically mentioned that x cannot be equal to 0, even though these things that x here, x not equal to minus 1 and x not equal to 0, don't affect your answer in any way. But I am stressing on these values because you always have to give special attention to these points. Alright, always keep these things in mind, even though we are not using it anywhere while our solution, but still you have to keep these things in mind. Alright, okay. Next question. We're given that two functions f and g such that fx is equal to x minus 3 and gx is defined in this way. Alright, now the thing that I am focusing on again is that this function gx, for if we take gx is equal to this value, then we cannot take x equal to minus 3 over here, right? Because in that case the denominator will be having 0 and division by 0 is not possible. So gx cannot have this value for x equal to minus 3. So that is why they have specifically defined some other value k when x is taking value minus 3. They can do that. Even if you want, you can design your own functions. You can define your function, say for example fx is equal to 0 if x is greater than or equal to 1, and otherwise x is equal to minus 1 if x less than 1. You can define your own functions as well. So just like in the question they have given a function, so they can take any function of their choice. They can define functional values differently at different points. That totally the choice of the person who is defining the functions. So what I want to say here is that they have given this gx a nature that if x not equal to minus 3, then my gx will be given by this formula, not actually formula, just this expression, I'm sorry. And when x is equal to minus 3, then it is taking some value k, because gx cannot have this expression because it is undefined at x equal to minus 3. Alright, so now the question asks what should be assigned to k, means what value of k should we choose such that fx is equal to gx for all x. That means we want fx and gx to behave in exactly the same way for all values of x. Alright, okay, let me erase some of these so that I can explain it better to you. Yeah. So consider this gx. This gx is x squared minus 9 by x plus 3. What do? We factorize the numerator. So x squared minus 9 is x plus 3 times x minus 3 divided by x plus 3. Okay, so now we can cancel out x plus 3 and x plus 3, but always make sure that whenever you're canceling something out, just don't forget to mention that x plus 3 is not equal to 0, because it is given that x not equal to minus 3. So x plus 3 cannot be equal to 0, because x plus 3 not equal to 0 means you can take plus 3 to the other side, means x not equal to minus 3, which is already given in the question. So this is the reason we can cancel it out. Otherwise we could not have, because x plus 3 could have been 0. But here we are assured that x plus 3 cannot be 0, because x is not equal to minus 3. So we can safely cancel these terms out. So you have to mention and we keep in mind these things. All right, so gx is equal to actually x minus 3 whenever x not equal to minus 3. Okay, so we can write gx equal to x minus 3 when x is not equal to minus 3. This is the value that gx takes when x is not equal to minus 3. And we want to define this k for x is equal to 3 such that gx and fx have the same values at all those points. So see that fx is x minus 3 and gx is also x minus 3. Fx is x minus 3 at all points for all x belonging to real numbers. That's the domain of f. And gx has this value at all real numbers except at x equal to minus 3. All right, so we want to find out k. What should this k be? So for that we just need to find what f is taking at x equal to 3. Okay, so f of 3 is 3 minus 3, which is 0. So at x is equal to 3, fx is taking value 0. Alright, so we also want g of 3 to be 0, right? Because in that case only fx and gx will be same. Fx and gx are already x minus 3 at all other values except for x is equal to 3. So we just have to make sure that at x is equal to 3, both of them take the same value. Okay, so we see that f of 3 is equal to 0. That means f is taking the value 0 when x is 3. So we just define this k to be equal to 0, because this is what the function value takes at x is equal to 3. So that's it. We define k to be equal to 0, and then in all the cases fx and gx behave in exactly the same way. So k is equal to 0 is our answer. Alright. Okay, now domains and ranges of real functions. Okay, so as of now we have just been discussing of domains and ranges with the help of ordered pairs. Remember, I used to tell you that if you are given some relation like 1 comma 2, 2 comma 5 and so on and so forth, then these first values, the left hand side values are forming the domain, and these right hand side values are forming the range, right? But to understand it in the context of functions, you have to just understand the definition of domain. So the definition of domain says that suppose there is a function fx. Okay, so this function has the form 1 by x minus 3. All right, so you can give this function any x. That means you can give it x is equal to 2, 4, 5, 6, anything except for x is equal to 3, because in that case the function will give you undefined results, because at x is equal to 3 the denominator will be equal to 0, right? So the denominator will become 0 at x is equal to 3. So that is why this function is undefined at x is equal to 3. Okay, so what you do, you say that domain doesn't contain minus 3. The domain is R minus 3, right? So this is how you define the domain. You have to exclude all those points for which the function is not defined. So I repeat, the domain is a set of all those values for which the function gives you defined results. So in order to write down the domain of some function, just remove those points for which the function is giving you undefined values. Okay, So this is what the domain is. The domain is the set of all those points for which the function gives you defined values. For which the function is defined. Alright? This is what the domain is. Okay, now what is range? So suppose that you plug in some value of x. Say for example, you plug in x is equal to 2. So what you'll be getting as its functional value? You'll be getting 1 upon minus 1, which is minus 1, right? So similarly, if you put down 3 in place, okay, 4 in place of x, so you'll be getting 1 over 4 minus 3, which is equal to 1 by 1, which is equal to 1. Similarly, if you go on putting the values of x, you will get some other values of the function fx. So you'll be getting different values, you'll be getting a bunch of values, right? You take the set of all those elements, all those values, you take the set of all those values, and that is what is called the range. All right. So what is domain? The domain is the set of all those values of x for which the function is defined, and range is all those values which the function can take. So you feed in some values of x, and the outputs that you give, the set of all those outputs is actually the range of this function. Okay, sounds theoretically good, but for any given function, how are you actually going to find out the domain and range of function? Okay, so that is why I have included a bunch of examples to make this thing crystal clear to you. All right. Okay, find the domain and range of the real function. Okay, let's concentrate on domain first. Remember the definition, it is the set of all those points that will give you defined values. Okay, so we have already discussed this example that this function actually gives you defined values for all real values except for x is equal to 3. So the domain is actually, so the domain is actually all the real numbers except the point 3, because this is the only point for which the function is giving undefined value. Division by 0 is not possible, so you can, otherwise you can take any real value, right? 2, 4, 6, 8, 3.5, 2.9, 2.99, except 3, right? You cannot take 3, else you can take any real number. That is why the domain is all the set of the entire set of real numbers except the value 3. All right. Now what is range? So range is set of all those values which the function will take. So how to find out the set of all those values? So the trick here is that you assign y is equal to this function, fx is equal to y. You just, instead of fx, you write down y, and then what you do, you make x as the subject. Okay, so what we do, we take x minus 3 on this side and y on the other side, and then take 3 over there. So x is equal to 1 by y plus 3. Okay, now understand, what is this y? This y is actually the set of all those values which the function can take. So you think of this x as, you put in some x, it throws you y. You give in another x, it gives you some other y. So we are interested in finding out what are the valid values of y that you can get, and it is better to understand the valid values of y from this equation. Now you forget about this and you think about this. So what are the valid values of y? So valid values of y are except 0, anything, right? So you can have any value of y except 0, because this is 1 by y, which gives you undefined value only for y is equal to 0. Except that you can have all the values of y freely available to you. So that means y can take any value except for 0. This is what that gives you the range of the function. So instead of y, you just write down the range is equal to this, r minus 0, because y can have all those values. So this is the trick. Remember, in most of the cases, what you have to do, you just, instead of fx, you write down y, and make x as the subject. So in the right hand side you will be having some y, and you just see what are the possible values of y that can come in. Ignore all those values. So actually effectively you have to think of the domain of this of this new function. What are the values of y which are prohibited, which are not valid? So you exclude those values, and it actually gives you the domain of the function. Sorry, range of the function. I'm sorry. So the domain is thinking about all those values that are to be omitted in order to get defined values, and range is the tricks unknown to you now. Okay, one more example. Find the domain of the real valued functions. It only asks us to find out the domain, so we will not be finding out the range of this particular question. Okay, even though if you want I can give you some hint, and if you want we can try as well. So let's first understand how to find out the domain. All right, so for finding out the domain we just need that this denominator should not be equal to 0, right? So what do? We find out all those values of x for which this function gives us undefined results. That means all those values of x for which the denominator is 0. We have to just find out all those values of x and then subtract them from the set of real numbers, and that is our answer, right? That is the definition. You subtract all those values of x for which the function is undefined. So we just factorize it. X squared minus 4x minus x plus 4 is equal to 0. X minus 4, x minus 1 is equal to 0. X is equal to 4 comma 1. So we see that when x is equal to 4 or 1, then the denominator is actually 0. So the domain is the set of all those real numbers, all the real numbers except this set 4 and 1, because these are actually the points for which the denominator gives us 0. So we exclude these points, and rest all of these points gives us valid functional values. So they are there in the domain, and that's it. Now think about the range of this function. So the range is a set of all those values which the function will take. So you given some input, it will throw you the output, and the set of all those outputs is actually the range. So the trick is, you in place of fx you write down y. So x squared minus x plus 1 divided by x squared minus 5x plus 4. So now what we do, we have to make x as the subject, right? So first we cross multiply and see what we can do. So y times x square minus 5x plus 4 is equal to x square minus x plus 1. Now what we do, we write it down in terms of a quadratic equation in x. So x square y minus 1, so this and this done. Then plus x, here we have minus 5y, and here it will be plus 1 because minus 1 will come to this side. And then all these constants which are plus 4y and minus 1. So this is a quadratic equation in terms of x. Alright. So we just want those values of y which will give us valid things. So what is x? We solve it using Sridharacharya. X is equal to minus b, that means minus of minus 5y plus 1. We just make x as the subject as discussed previously. So from this quadratic equation we find out the value of x using the Sridharacharya formula. So minus b plus minus root over b square, so minus 5y plus 1 whole square minus 4 into a into c whole divided by 2 times a, right? So this is the value of x. So you have to make sure two things. First of all, that y cannot be equal to 1, because in that case the denominator is getting 0. So y cannot be 1. So the range cannot have 1. Alright, because there is no value of x for which you can get y is equal to 1. It will give you undefined results for sure. So range cannot have 1. And the second thing you have to be careful about this, that this thing under the root cannot be negative. So what you have to do, make this entire thing greater than or equal to 0. So I'm writing it down over here. minus 5y plus 1 the whole squared minus 4y minus 1 and 4y minus 1, this entire thing has to be greater than or equal to 0, and then you solve it. So whatever the values you get, they are actually acceptable. So in order to find out those values of x which are not acceptable, you find out less than 0. So from this set you have to solve it. I'm not solving it because the question doesn't ask us to find out the range. I'm just giving you a hint how to proceed with the example for any question. So first of all, you have to subtract this one, and secondly you have to subtract all those values of y that you get from this set, and that will be your range, and that's it. All right, this is a bit difficult, I know, and that's probably the reason they have not asked us to find out the range, but this is how you should proceed for finding out the range of this function. All right, next question. Find the domain and range of root over x minus 3. So what about the domain? We know that for any function, this whenever we are getting root over negative values, that is undefined, right? So root over minus 9, root over minus 3, all these are undefined, right? So for this function to take defined values, we cannot have negative numbers inside the root. So that means x minus 3 has to be greater than or equal to 0. This is the set of all those values of x for which the function is defined. So that means we need to have x greater than or equal to 3. This is the domain. Remember, we are not going the other way around. We are not finding out those values of x for which the function is undefined. Rather, we straight away found out those values for which the function is defined. We didn't do it the other way. We straight away found out all those values for which the function is defined. All right. Okay, so we need to have x greater than or equal to 3, because if you take anything less than 3, then it will give you undefined result. It will give you negative numbers inside the square root for which the function will be undefined. So the domain is x greater than or equal to 3. In interval form, you will have to write it like this. All right, if you don't know about intervals, look into my previous videos. All right, so what is the range? Okay, so I told you that to find out the range, what do? You, instead of fx, you write down y. So fx is equal to root over x minus 3. All right, so what you do, you make x as the subject. So you square both sides. Y square is equal to x minus 3. Then take 3 to the other side. So x is equal to y square plus 3. All right, so what are the values of y that are possible? All the real numbers, right? So y can take any real number. So that seems to be the range of the function, right? But actually, if you think this function fx is equal to root over x minus 3 can never take a negative value. Say for example, it can have root 2, root 3, root 4. So all these values will be actually positive. We cannot have negative values, right? So this is actually the range of this function. The range is the set of all positive numbers, 0 to infinity, 0 included, because at x is equal to 3 you'll be getting 0. You cannot put negative numbers, and if you put anything greater than 3 like 4, 5, 6, you'll be getting root 1, root 2, root 3, and so on, and all these values are actually positive. So the range is positive. One more question. What is the domain of fx is equal to 2 minus 3x? Okay, so clearly there is no value of x for which this function will be undefined. So the domain is the set of all the real numbers. Okay, what about range? So what do? Instead of fx, you write down y is equal to 2 minus 3x, make x as the subject, 3x is equal to 2 minus y, and x is equal to 2 minus y by 3. And here also we see that there is no value of y for which the function is undefined. You can have any value of y. So the range is also the set of all the real numbers. Alright, this was an easy question. Okay. Again, the domain and range. So we see that there is a denominator, so we have to make sure that we do not have a 0 in the denominator. So we do not want a 0 in here. So let's find out for which value of x the denominator becomes 0. So we solve it. 3 is equal to 2x and x is equal to 3 by 2. So this is the value of x for which the denominator becomes 0. So what we do, we just remove this value because this is the only value for which the function is undefined. So we are going that way. We have to remove all those values for which the function gives you undefined values. Otherwise, you can take any real number. So this is our answer. This is our domain. And for finding out the range, you proceed in the same way. Take y is equal to 2 minus 3x by 3 minus 2x, and then you make x as the subject. So 3y minus 2xy is equal to 2 minus 3x. Take all the x on one side. So 3x minus 2xy is equal to 2 minus 3y. Take x common. 3 minus 2y is equal to 2 minus 3y, and x is equal to 2 minus 3y by 3 minus 2y. Okay, so here we have to find out what are the values of y which are acceptable. So you can have all the values except for which this becomes 0. So y can take all the real values except this cannot be 0 because that's a denominator and we cannot have a 0 in the denominator. So that means y is equal to 3 by 2. So again we are having the same range. Range is also the same as domain, coincidentally for this case. The set of all real numbers minus this point 3 by 2. That's it. The domain and range are in this case both the same. Okay, this is a special type of function which is called as a modulus function or absolute value function. So let me first tell you the definition of this function. So suppose that you are given mod of minus 5. So the output is 5. And similarly, if you are given an input of minus 7, the output is 7. So the function, what it does is that if you feed in some negative value, it makes it positive. But if you feed in some positive value, it doesn't change it. So say for example, the mod of 6 is actually equal to 6. So in any case, we'll be having a positive value as its output. Okay, so it is actually a bit confusing, but try to remember this. So this function is why is called the absolute value function, because it is just concerned with the absolute value or the magnitude of the value that is inside it. So the magnitude of this minus 5 is 5, the magnitude of minus 7 is 7, the magnitude of 6 is 6. Magnitude is the weightage of a number irrespective of its sign. That is why this function is called the absolute value function. All right, so we define an absolute value function like this: mod x equal to x if x is greater than or equal to 0. That means that the input and output are actually same. You give it 6, it gives you output as 6. If you give it an input of 5, it gives you output of 5. It gives you, if you feed in the input of 10, it gives you output of 10. So that means this mod x is x whenever this x is something positive, or even if 0, doesn't matter. But it will give you minus x for x less than 0. That means suppose you feed in the value minus 5. So what it does, it multiplies it with a minus sign. So it for a some time it might think that, hey, minus x is something negative, but no, x is negative, so minus x is positive. So this is how this function deals with numbers. If you give it a positive value, it doesn't change the number, but if you give it some negative value, it multiplies that number with a negative sign to make this number a positive number. So this is actually positive because you feed in some negative value, x less than 0, and then you multiply it with the negative sign. So that means this entire minus x is actually positive. This is how this function works. So given any positive value, it throws the same value, and given any negative value, it multiplies it with a negative 1 to make it positive. Okay, all right. So now the question is given to you like this: fx is equal to x minus 5. Okay, So fx is equal to mod x minus 5. So what are the values of x for which the function is undefined? There is no such value of x. You can take any x as you like. So if you take x something greater than 5, then it will give you some positive number, and if you take something like x less than 5 like 4 3, so it will give you mod of some negative number which will also become positive. So there is no such value of x for which the function will give you undefined results. It will give you defined results for all the cases. So in that case, the domain becomes the entire real line. Okay, you can take any x and you apply these rules over here, and that's it. Okay, now what about the range? Range is a set of all those values the function can take. So we already know that this function cannot take any negative value, it can take only positive values. So that's actually the range of this function. 0 to infinity, only positive values, and it can also take the value 0 at x is equal to 5. So 0 is included, closed interval, closed at 0, and this is the range 0 to infinity. Okay, one more question. The domain and range of root over 9 minus x squared. Okay, so we know that inside the root we cannot have a negative number. So for the domain we need 9 minus x squared to be greater than or equal to 0, right? We do not want it to be negative, so this is actually the domain. We straight away find out those values for which the function is defined. All right, so 9 greater than or equal to, okay, let's factorize this. Yeah, so it's 3 minus x times 3 plus x greater than or equal to 0. Now this has to be understood. Okay, so you are given two numbers, 3 minus x and 3 plus x, and you are told that when you multiply these numbers it is something positive. So what are two cases? The two cases are that either both of the numbers are positive, because in that case multiplying two positive numbers will give you something positive greater than 0, or the numbers can both be negative, because if you multiply two negative numbers as well you get something greater than 0, that means positive. So there are two cases. Case 1, either both of 3 minus x and 3 plus x are positive. Positive means greater than or equal to 0, remember. Or the second case is that both of these 3 minus x and 3 plus x are negative. Okay, so let's take this case first. So 3 minus x greater than or equal to 0 means 3 greater than or equal to x and 3 greater than or equal to minus x. That means x less than or equal to 3, and you take x to this side and 3 to the other side, so you get x greater than or equal to minus 3. So this says that x has to be less than or equal to 3 and greater than or equal to minus 3. So you think of it in the real line. Minus 3 is somewhere here, 0 and then 3. It says that x has to be less than 3 and greater than minus 3. So this is the common portion, right? So these are the values of x which we get from this first condition. Okay, now take the second condition. 3 minus x less than or equal to 0 means 3 less than or equal to x and 3 less than or equal to minus x. So from this we get x greater than or equal to 3 and take x to this side and 3 to the other side, x less than or equal to minus 3. So we need x to be 3 greater than 3 and less than or equal to minus 3, which is not possible. Why? Think of it in the real line again. So we want x to be less than minus 3 and greater than 3, which is not possible, which cannot happen. So you give the reason, this is inadmissible. So this is the only thing that we are left with. So x lies between minus 3 and 3. This is our domain, because if you take anything between -3 and 3, then inside the root you'll be getting something positive. So you take, say for example, -2, 0, 1, it will give you something positive inside the root. But what if you take anything outside this range? Say for example, you take 4 or -4, 5, 6, or -5, -6, you'll be getting something negative. Try it out. If you take x is equal to -5, then it will give you 9 minus 5 the whole squared is 25. 9 minus 25 is negative. So under root negative is undefined. That is why uh, we we are getting this domain -3 to 3. And for range, it has already been discussed that whenever you are given something inside the root, it can never take some negative value. You can never get -3 -4 or -√3 -√4, because this square root is conventionally positive. We call it conventionally positive because the first thing is that you cannot have a negative number inside. So it is always either 0 or positive. So root over something positive always gives you positive value. So the range is actually the set of all positive values, 0 included, because at x is equal to 3 or -3, you'll be getting 0, and any positive number you can get as range, but cannot get a negative number as its range, because it is always conventionally positive. We call it conventionally positive. Okay. All right. One more question relating to this absolute value function. You have to find out the domain of this function. Okay, so for domain we need that we cannot have, first of all, we cannot have a negative number inside the root. So generally what we are given is like the function of this form, fx is equal to root of something. But here the question is a bit tricky. We are given fx is equal to 1 by root over something. So initially in here 0 was acceptable because root over 0 is 0. But for these cases under root 0 is not acceptable, because in that case we'll be getting something like 1 by 0. So here we have to make sure that the denominator is strictly positive, because it cannot be negative because of this square root. We cannot have negative values in the square root, and we cannot have 0 because this entire thing is the denominator. So if you have 0 inside this x plus root x, instead of x plus root x you have 0, so it will be 1 by root 0, which will again be undefined. So what do we need? We need x plus root x to be strictly greater than 0. This will give us our domain. We have to simplify this now. Okay, so we have to simplify, and that will be our domain. Okay, so now what are the values of x for which this thing holds? Okay, so think of two cases: x greater than or equal to 0 and x less than 0. We have to find out which of these conditions are acceptable. Think of any positive value. So if you take any positive value, say for example you take 2 plus mod 2, you'll be getting 4, right? So that is greater than 0, so that is acceptable. Similarly, any positive value will be acceptable. But what if you take any negative value? If you take any negative value, then what will happen? So suppose if you take -5, so what will happen to this? -5 plus mod of -5, which will be equal to -5 plus 5, will be equal to 0. But we want it to be strictly greater than 0, because we cannot have 0 in the denominator, right? So negative values will be inadmissible. Similarly, if you try with any negative number, -6, -7, -8, or any negative number, you'll always get 0, and that will give you inadmissible result, not an invalid results. So that is why we cannot have anything less than 0. Okay, what about x is equal to 0? So for x is equal to 0, we'll be having 0 plus mod of 0, which is 0 plus 0, which is 0. Again, which is not acceptable because we cannot have 0 in the denominator. So the only possibility left is this. We can only take x greater than 0, and that will be our domain. So in the form of interval, it will be 0 to infinity, and 0 is not included, strictly greater than 0. Alright, so that is our domain. Alright, and the range is any positive number. 0 to infinity, and it cannot have 0 at any value, otherwise it can take any positive value. That is our range. Alright, because square root is conventionally positive, So 1 by something positive is always positive, so it can take positive values and it cannot take 0. So that is why it is open at 0. This is our range, even though the question didn't ask us, but still for your understanding. Okay, now the last type of functions we are interested in is the greatest integer function, also called as the step function, or also sometimes called as the box function. So this is defined or denoted as this: fx is equal to box x. This is how we denote a greatest integer function. Okay, so what does this mean is that suppose you plug in some decimal values like 3.2. So what this function will do, it will throw you 3 as output. So that means it will take the greatest integer which is just less than the number. It will not give you rounded off. Say for example, if you take 3.8, it will still give you 3. So the definition says that whatever number you take, it will give you the integer just below that. So if you take 3.2, the integer just below that is 3. If you take 3.8, still the integer just below that is 3. If you take 4.2, the integer just below that will be 4. So the output will be 4. That means box of 4.2 or anything 4.3 is 4. So the integer just below this. This is the definition of greatest integer function or step function, also called as the box function. Okay. Now, can you tell me what is box of minus 2.5? Did you say minus 2? Sorry, you are incorrect, because minus 2.5 and minus 2 is greater than this, but we want the integer just less than this, right? So which is minus 3. So this is a quite tricky example. Make sure you're understanding it properly. Greatest integer means the integer just less than the number. So the integer which is just left to minus 2.5 is minus 3. Okay. Now, the domain and range of 1 by root over x minus box x. Instead of absolute value of x, it is having box x. Okay. So, consider these examples. Suppose you take x belonging to any integer. Okay. So, again, remember that this is the same format, root over something. So, we need to make sure that x minus box x is always strictly positive. It cannot be negative because of that under root, and it cannot be 0 because it is in the denominator. Alright, so what are the values of x for which this condition will be satisfied? That will form our domain. So let's consider two cases. You take x to be any integer. If you take x to be any integer like 3, 4 or 5, suppose you take 3. So if you put x is equal to 3, so you'll be getting 3 minus box of 3, which is equal to 0. Right? So this is inadmissible. X cannot be any integer. Okay? Now think, if you take x to be any non-integer value like 4.5. So if you take x is equal to 4.5, then what you'll be getting? You'll be getting 4.5 minus 4, because box of 4.5 will be 4, will be giving you 0.5, which is of course greater than 0. Okay? Alright. So these are the things that we have considered for positive x's. So for you have now known that you can take any x positive value except for integer values. Okay, now what if you take some negative value? So if you take, say for example, minus 4, then minus 4 minus minus 4, which is minus 4 minus minus 4 only, because box of minus 4 is box of minus 4 itself. Remember, I didn't tell you, sorry, box of some integer is the same integer, like box of 2 is 2, box of 3 is 3, box of 4 is 4, box of minus 2 is minus 2, and so on. So this will give you again 0. So for any integer we'll be getting 0, right? So any integer is inadmissible because we cannot have 0 in the denominator. And what if you take some negative decimal like minus of 8.3? So minus of 8.3 minus minus of 8.3, which gives you minus 8.3 minus, what is minus of 8.3 ka box? That gives you actually minus 9, right? because minus 9 is just left to minus 8.3. Make sure you don't mess around with it in an examination. Don't write it as minus 8. Okay, so minus 8.3 plus 9 again gives you something positive. 0.7 is positive. So that is acceptable. So that means our domain is all the real numbers except for integers. Otherwise, you can take any number, positive or negative, anything will work except for integers. So that's our domain. And what about the range? The same thing, because it is under root, so it has to be positive, uh, and it cannot take the value 0, so it is open at 0, and this is the range because under root is conventionally positive. Okay, all right, so we are done with this domain and range. I hope I made the concepts clear to you to the best of my capabilities, and we had discussed a lot of examples. We discussed real valued functions, we discussed about modulus functions and absolute value functions, and we also discussed about greatest integer functions. And finally, we discussed about domain and range of function. I hope this makes things clear to you. And now what you have to do is practice a bit harder to get the concepts even better and clear. Thanks a lot. Stay tuned with A level maths. Bye bye.